Hi everyone and welcome to my channel, Indian Seed. In this video, we will discuss the nature of mathematics and other subtopics under the chapter 1. Patterns are regular, repeated, or recurring forms or designs. To better understand patterns, we have here 3 examples. Number 1, we have a set of figures, star, triangle, triangle, and the next term, triangle, star, and a triangle. So the third term, from observation, we can notice that in the first term, the star is in here, and the second term, the star is moved here. So the third term, in the third term, it will be a triangle, triangle, and a star, where the star is in the third place. The second example, we have 1, 3, 5, 7, and so on. And we have to find the 10th term. We can notice that this is an arithmetic sequence where we have a constant distance between the terms, which is 2. We have a formula for arithmetic sequence, which is a sub n equals a sub 1 plus the quantity of n minus 1 times d. So just using the formula, just simply substitute the given, and now we get the a sub 10, which is 19. In the third example, we have 2, 8, 32, and so on. And we have to find the sixth term of geometric sequence, which is a sub n equals a sub 1 times r raised to n minus 1, where r is the ratio of the terms. We can get the common ratio by dividing the terms in the sequence. As you can see here, 32 divided by 8 is equals to 4, and 8 divided by 2 is equals to 4. So we get the common ratio, which is the 4. And again, by just substituting the given, which a sub 1, which is the 2, the r, which is 4, and the n, 6, minus 1, we get 2048. The term symmetry indicates that you can draw an imaginary line across an object, and the resulting parts are the mirror images of each other. This type of symmetry, known as line or bilateral symmetry, is most evident in animals, including humans. This is known as rotational symmetry. The smallest figure that can be rotated while still preserving the original formation is called the angle of rotation. A more common way of describing rotational symmetry is by the order of rotation. So in order of rotation, we also have 3 examples. The first one is the triangle. In order of rotation, we just use the formula for angle of rotation, 360 over n, and n is the number of angles. So for the first example, 360 divided by 3, since the triangle has 3 angles, we get 120 degrees. So if we rotate the triangle by 120 degrees, we also get the same image as it is. And that is the rotational symmetry of the triangle. In the second example, we also have here a square using the formula 360 over 4. Since a square has 4 angles, we get 90 degrees. And the rotational symmetry of a square is 90 degrees. For the last example, we have here an hexagon. For the third example, we have a hexagon. By using the formula 360 over n, since we have since a hexagon has 6 angles, we get 60 degrees. Packing problems involve finding the optimum method of filling up a given space. We go now to the packing problems, in which we have an example. Find the area of the largest circle which can be cut from a square and from a square of edge 10 cm. What is the area of the material wasted? So we have a formula for the area of circle, pi d squared over 4, and the area for square is a squared. First, we have to get the area of square, which is 10 squared is equals to 100 centimeters squared. And next we have the area of circle, which is pi times 10 squared over 4 equals 25 pi. Since we need the area of the material wasted, we have to subtract the area of square from the area of circle. So we get 21,460 square centimeter. For the second example, find the volume and total area of the largest cube of wood that can be cut from a log of circular cross-section whose radius is 30 cm. So we have the radius is given, which is 30 cm. So we can get the diameter, which is 2r. 2 times 30 cm is equals to 60 centimeter. Since the diameter is also the diagonal of the square, we can derive a formula from there, in which we just have to divide d and a the square root of 2 by square root of 2. So we can cancel square root of 2. So the formula for a is d over square root of 2. By substitution, we get 42.46 centimeters. Now, since we have the value for a, we can also get the volume and the total area of the largest cube of wood. For volume, we have the formula a cube, and by substitution, we get 76,365.335 centimeters squared. And for the total area, we have the formula 6a, and by just substitution, we get the total area, which is 10,799.793 square centimeter. Mathematics can be used to model population growth. In the word population, we also have examples. In the first example, in 1950, the world's population was 2,555,982,611. With a growth rate of approximately 1.68%, what was the population in 1955? So here, we also have a formula for exponential growth, which is P equals P times E raised to R times T, in which P is the population, E is the constant, which value is 2.718, and the rate R in decimal form, and the T or the time in years. By direct substitution of the given values, we can get, now we have, so the world's population, 2,779,960,540. For the second example, in a barangay, if the population is 18,585 in 2015 and approximately the growth rate is 2%, what would be the population in 2019? Again, by using the formula for exponential growth and direct substitution and changing the rate into decimal form, and now we get 20,132.89. But since we are talking about population, we have to round up or round down the final answer. Sequence is an ordered list of numbers. The arrangement of these terms are set according to a definite rule. Fibonacci sequence is formed by adding the preceding two numbers beginning with 0 and 1. We have here the Fibonacci sequence. This sequence is formed by adding the preceding two numbers beginning with 0 and 1. So basically, we just have to add the preceding two terms. For example, 1 plus 1, we get 2. And 2 plus 1, we get 3, and so on. Continuing to the seventh term, here we have 5 plus 8, we have 13. So 13 plus 21 is 34. 21 plus 34 is 55. So the 10th term is 55. And the next term, 34 plus 55. 34 plus 55, we get 89. And that's all for this video. Thank you for watching.